Hey everyone, so today I got my friend Cyclops, and we're going to be doing a coding interview, a mock coding interview. So, simulating a coding interview that would actually happen at a fan company or like a startup that likes to ask lead code. This is going to be very lead code style. I know a lot of startups are starting to do practical. Maybe I'll get into those soon, but I just easier to just pull a question off lead code. So Cyclops, could you just walk me through your background so I could figure out the questions I should ask you?
Yeah, so right now I'm a grad student based out of New Jersey, and I'm kind of just prepping right now for like the fall like applications that will like open roughly like around like a couple months. Um Kind of like the company scope that I'm trying to aim is like kind of in that range of like Datadog or like MongoDB or
Hmm.
something in that range. Like not really like scope is kind of like out of or Fang is kind of like out of my scope. Like I'm not really shooting for Fang. I'm kind of shooting for like those types of companies like
Hmm.
Datadog or something similar like Gusto, uh stuff like that.
You don't want
Yeah.
to get into Fag?
Yeah, like Fang's kind of out of my scope. Like and it's not like that I'm not applying to Fang. Like I still apply to Fang. No luck so far. Like of course like if I end up getting like a Fang position, then obviously I'm gonna take it for sure. But
Hmm.
it's kind of like that's not really what I'm shooting for. I'm shooting for like more like medium sized like companies.
I see. Okay.
Yeah.
Let's see. So, do you go to a top school? People are asking.
Not really. I go to like a private institution in like Jersey. I'm like right on like the Hudson River.
Hmm.
It's not like a huge school. Not like an NYU or like anything like that. Like a Columbia. Um, but I still say like it's a pretty decent school. I guess like if you live around here, you kind of know the
What's the
school.
name?
Stevens Institute
Nice.
of Tech. Yeah.
Cool. So your master's is in computer science.
Yeah, it's in software engineering, which is basically the same. Yeah,
Okay.
it's the same thing.
Okay. What's your leak code breakdown? Easies, mediums, and hard.
By breakdown, do you mean like kind of like my comprehension of like the
Or
difficulties?
how many easies have you solved?
Um, Probably like maybe like 40 easies and like like high 20 mediums and like maybe just like a hard like here and there. Like I haven't really touched hards at all.
Okay. Um,
Yeah.
how familiar are you with arrays? Give yourself a score out of 10.
With arrays, definitely like out of 10, definitely like a 7 or an 8. Like I have the fundamentals like pretty strong, but obviously like when it gets kind of like the question gets kind of like weird with arrays sometimes, so I could improve like in those types of questions.
Okay.
But yeah.
What about linked list?
Linked list, probably like a 6.
Okay.
Yeah.
Trees,
Trees, like a 5.
graphs.
Graphs definitely like a 4, a 3.
Okay.
Yeah.
What about like BFS, DFS? I mean, that doesn't. Okay. What about greedy and or dynamic programming? I'll ask you that. Dynamic programming.
Dynamic programming, I haven't like really looked at them in
Okay. Okay.
dynamic
Okay.
programming
Like
either,
any
actually.
not applicable. They don't really ask that too much in interviews, honestly. Binary search.
That like an 8 or 9. Yeah.
Okay, looking at this breakdown, definitely focus on arrays, but you need to get the trees and graphs higher because those are the most common that you'll see in interviews. So
Okay.
understanding trees and graphs are very important. Um, yeah, like every interview process I had, at least one or two of the questions was a tree or graph question. There's some array questions, but yeah, I would focus a bit more on that from just looking at the breakdown. But cool.
Yeah.
All right, let me look for a good question real quick then, and then
Okay.
I'll invite you to the lead code session. All right, yeah, this is the first question. Yeah, go ahead and read through that question,
Okay. Yeah.
and yeah, take some notes on what you figure out there or what you're thinking as well.
Okay. So If true if and flowers can be. Okay, so just immediately like my thought process is so let's say we have this example here. This is this first one. So my immediate thought process is we can loop through all the indices, right? And we have this n is equal to 1 for this first example, right? So this is the amount of flowers that we must plant in the array. So if we loop through the if we loop through this list, we can check, okay, like if the positions like to the left and to the right are not like don't have flowers, then we can plant a flower at the current position. Like if the current position doesn't already have a flower in it, right? So here, like we already have a flower. I think the only thing that I would have to figure out is the edge case where like I'm checking like out of bounds here. So if I start here and I check to the left and to the right, then I'm checking out of bounds like on the left side. But for now, like, so that's like the immediate thought process. And then, so here I see that I have a flower. So I can't plant my flower here. So I would move on to the next index and I would see, okay, I see that this index is empty, but is the index to the left and to the right, are they both empty? Well, the one on the left is not empty. So I would have to continue to the next one. And then here I see that this position is also empty and the ones to the left and to the right are empty. And then I would go ahead and add a 1. Like I would replace this like value to be a 1. And I can decrement like my n value to like 0, right? And then I guess like once this reaches 0, this n value, then I can return true, right? And if I loop through the whole like list, and after if I check n, if my n value is not 0, then I can return false, because that means that I haven't planted all my flowers, which means it wasn't possible. So let me think of like how I can deal with like this edge case, like the left or the right. Integer is true. Okay. So I guess like if, for example, like if let's say like this is 0, because like a left value doesn't exist on the left here, but a right value does exist on the right, but but there's no flower on the right, then I'm able to just plant the flower right here, like on the left and right, like edges of the list, yeah. So I think like an easy way to solve that is what I would do is I can just modify like the list. I would modify this list and I would make like a new list, let's say, and I would add like zeros to both like the left and the right side. To kind of signify, so like if so I'm not like checking out of bounds, right? And I can check like, and basically this is basically a 0, like nothing on the left is basically just a 0. And yeah, and then so when I loop through all this, then if I check that, if this is 0, then I can return true or false otherwise, right? So that's my thought process.
Okay.
Yeah. So I'm not sure if that sounds good with you, but I can like go ahead and code it up.
Yeah, go ahead and code it up.
Okay. So let's see. So I want to see if I can just straight up just modify this, like the current array that I'm given. So
I don't know if it's on your screen too, but I'd write it into the function.
oh, yeah.
Because sometimes it tweaks. Okay.
Yeah, you're right. Okay. So Let me just go ahead and like print this because I just want to double check that I'm actually like getting what I'm expecting. Okay, yeah. So that's kind of what I want. So from here, I can say, so for flower in the flower bed, right? Or actually, no, I have to search through the indices instead. So for I in range, the length of flower bed, we can say, and we want to start at, I want to start like here, right? I don't want to start here.
Mm-hmm.
So because this is just like a placeholder.
Sure.
So I want to start like at 1, and I want to go up to the length of this -1 because I want to end like right here, like at the like before the ending, the final placeholder, like on the right. Um, and then here I can say, if the flower bed at I is not equal to 0, or well, if it's not equal to 1, right? If it's not equal to 1, and flower bed at negative or 1 minus or I minus 1 is not equal to 1, and flower bed at I plus 1 is not equal to 1, then we can say, so if the current index is not 1 and the ones to the left and to the right are also not 1, then we can plant, we can decrement 1 because we know we can plant a flower.
Sure.
And we can modify the current index to say flower bed as I is now equal to 1, right? We just change 0 to 1,
Sure.
right? Otherwise, we just continue on with the whole like for loop, and at the end, after the for loop concludes, we can say return if n is equal to 0. Right? I believe like that might work. I think I can do a test run.
Yep. Looks like it failed
Or like
on one.
so
Do it. Yeah. Do a dry run. Do a dry run.
yeah. So let me do a dry run. So so for example, let's take the first example.
Let's take this example down here.
Okay, so let's do this. I'm gonna run it like within like the lines of my code here. So for I in range 0, 1, so we start. Well, here we modify it, so we actually add like another 0 to the ends, right?
Yep.
Okay, so here we see, okay, so we start at this index 1, and we say if this is not equal to 0 and the one before it is not equal to 0 and the one after it is not equal to 0, well, and it's 1, right? Yeah, so so I can just do, I replace this with a 1, and then we move on to the next one.
Or this is the solution or that one. It will work for that, but let's go through this one.
Through the one you have commented
Yeah.
down here, right?
Yeah.
Okay.
It's like n equals 1.
Okay. Let's see, return true in flower. Oh, well, yeah, okay, so here we start at this position, we see, okay, it's equal to 0, and the left ones and the right ones are also equal to 0. Then we can change flower bed of I to be 1, right?
Okay. Sure.
And we decrement this to 0.
Okay.
I think we can just straight up check, like, if this ever reaches 0, like within the for loop, then we can just like return true, like right away, actually, like within the loop. Like we don't have to wait until it loops through everything
Like right now,
Right.
it's returning the wrong answer here. Like with your code, it will return false, but it's true here.
Okay.
But yeah, I just want to see if you could catch that. Like, why is it returning false? Why would it return false when it's
Because we're decrementing like past 0,
yeah.
so that's why it's false. Yeah.
Mm.
Okay. So um, so here we can say, okay. So I just want to move this. So, and if like then we can just return true, right? And then here, like if this ever exits, then we'll just return false. I think this will be fine. Um, I believe that's why. So I think if I test it, if it just replaces this with 1, then it'll decrement, it'll replace it with 1. If n is equal to 0, we can return true.
If n equals to 0, return true. Yeah. This is
Otherwise,
like
it
a
just
weird
exits.
edge case right here. Let me look at it. It's basically there's a weird edge case if n equals 0. Try submitting and you'll see.
Okay,
Can you try to
let's see.
debug that case?
Yeah, let's see it. Okay, well, okay, that was the edge case. Well, I think like before we even do anything, I can just check like if we're not planting any flowers, right? Then like we can just return like true right away, right? Because it doesn't matter like how the flower bed
Yeah,
is like
exactly.
is. Yeah. Okay.
Cool.
Nice.
Nice. Cool. All right. Could you exit this one and
Yeah.
just exit?
All right. Cool.
I'm gonna bring you to the next question. I'm gonna send it on Discord.
Okay.
Yeah. Good job on that though.
Thank you. Okay. Okay. Let me read this question. So, if you're given n by n 2D grid, which represents the map of ones and zeros of water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. Um, you may assume all 4 edges of the grid are all surrounded by water. Okay. Okay, so I think the first well the first like immediate thing that I noticed is that this is kind of like a BFS question. And let's see. Um give me another minute to think about this actually.
What are your thoughts so far? Or like, what did you get out of the question that you think so far?
So I think this is like definitely like some matrix like BFS question.
Hmm.
And I think that so horizontal or vertically. So right, so let me go ahead and let me take this like this matrix from the
Sure.
results or the examples. So so like if we start like let's say like we start from the top left, we can check like all the values like to the like up, down, left, and right of it.
Hmm.
And check like okay, is it still like an island or we've reached like water, right? If it's still an island, then like we can continue the like traversing like with the BFS up until like we've like reached like all directions that are like that are water. Um, and I guess like we can keep like so it doesn't like loop forever, like go up and down like and left and right forever. We would keep like a visited like hash set, um, where we can keep our scene values like in here, right? Um, the one edge case that you would have to keep in mind is that if we're ever like at an edge of like the matrix, we can't like traverse like out of bounds.
Mm-hmm.
So you would want to always check like if like when we're traversing, you always want to check like to not like traverse like out of bounds. And then I guess like to do that we would have to like keep the length of the grid like using like two variables called like row and column, and we can have like one is like grid and one is like grid of zero, right? um and then to make it like really easy with this BFS, I guess we can also like initialize like some directions like variable, and this is like where um we can like so like when we're doing the BFS, we can call like this direction, so we don't have to write like up, down, left, or right like within the loop. Like we can just call this, so like we can have like we can do like this. Um, so this is like signifying like to the left, to the or to the right, to the
Okay.
left,
The,
yeah,
the, the DFS
etc.
part makes sense. How are we going to count the number of islands?
Um, so I think like how we would count it is I think like once you reach like so once you've kind of like explored all like the indices, and like we can like keep exploring anymore because it's either like water or it's like invisited, right? Then we know that like this like the island is like we're already like at the limits of the island, like it can't go any bigger than this. So we know that this whole like section is one island, like a single island, right?
Yeah.
um and then we would like keep like islands counter, and we
Okay.
would set this to zero at the first, and then we would increment it with whenever we reach that like case, right?
Okay, go ahead and implement the code. Looks like you're going the right direction.
Okay. Okay, so let me just see. So okay, so first let's just do like our rows, or let me just make sure that I'm in the in the function first. Let me just do it up here.
Sure.
So rows and columns, right? We can have this equal to, this will keep track of like the size of our like matrix. Um, um, we can do the directions, and let's see, we can do like or actually let's just, I don't want to do like tuples, let's just do like a list. 1 0. Okay, so like whenever we want to go to any horizontal or vertical direction, we would call this list, right? um and we'll do like a visited is equal to like a set, so this will keep all of like the directions that we have already seen, so we don't revisit them. And we'll have like a num islands counter, and this is like what we're gonna return like at the very end of our like call like BFS, right? So um so how I think I want to do this is I maybe want to I maybe want to like define like a helper function within this function. And this like helper function will take like the row and column that we want to like that we're currently at, like where we're like we want to traverse basically. Like before I write that, let me just like so let me just like do the loop. So like for the traversal, so like when we have to call like this helper function, right? So to traverse through this matrix, we can do for R in the range of rows, and then for C in the range of columns, we can say if this current matrix that we're at, if it's not water, so if it's equal to, these are strings, right? Yeah, so it would be this. So if it's not water, if it's an island and we haven't seen this position in our visited like list, then we can
JN, thank you.
we can
Appreciate you.
call like our helper function on the with these two like indices, right? And then let me just from here let me write the BFS actually. So the BFS we're gonna use like I want to use like a double-ended queue, so we're gonna just like import our
For this question, do we want to do a BFS or a DFS?
we
What
want a
is it?
BFS.
Okay.
Yeah, so I want to do a BFS. I guess like yeah, I want to do a BFS because I want to like from the like the queue, right? I want to like pop from the left side, so that's why we're doing like a deck here. Okay, so okay, so we'll just call our queue like queue, and we're gonna go ahead and we're gonna append these two like indices to our queue like right off the bat. So we'll append these two, and we'll also append them to the to our like visited set. I believe it's like dot add to add them. Yeah. Okay. So from here, what I want to do is so while there exists like a queue, right? So like while there are like positions that we have to visit in the queue, we're gonna do well, we're gonna pop from the left side. So we'll just say like current like row, current column is equal to queue dot pop left, right? And then from these two positions, I want to call like this directions like list, because from these two directions, I want to traverse like both up and down and left and right.
Sure.
Right. So um so I guess an easy way to do this is so what we can loop through this like list that we have up here. So we'll do like for directions left or directions row and directions column and directions. We can how we're gonna do is we're gonna add this and this, and we're gonna add this and this basically. So like to go up, down, left, and right. So and then we'll save that to like a new we'll save that to like a new thing called like new row, new column, and then this is equal to current row plus like the direction that we want to like traverse, and then the new column is the current column plus the direction of the column we want to traverse. And then so from here we can just so here we're traversing basically, we're checking the new we can use this to check the new like positions, and we can say from here we can say, well, first we want to check like if we're not out of bounds, right?
Mhm.
So because we could be like on the edges of this grid and we can go out of bounds. So I guess like in our if statement we can say, so if new row is in like the range of rows, and new column is in the range of columns. Okay, so that checks like if we're in bounds basically. And now we want to check like if we're checking an island, we're looking at an island. So we can say and grid add new row and new column is if this is equal to 1, and this and we haven't already seen this, right? So we also have to check and if this new row and this new column is not in our visited. So if it's not in our visited and it's an island and it's not out of bounds, so we can take this like new position that we just found and we can add it to our queue actually from here. So we can do like we can do new row and new column, and then from here we can also append it to our visited like hash set. So we can do new row, new column, right? And then I think what happens is this gets called like this continuously like gets called on itself, because like we will keep having a queue until one of these conditions is not met. So once it's not met and like the queue ends up being empty, that means that we've traversed like the whole island that we're looking at. So that means, so I think like once this BFS gets like returned, like the call gets returned, then we can go ahead and I think we can just increment from here like our islands count, right? And I think if everything is okay, I think I
Nice.
did that fine.
Cool.
Okay.
Yeah. You got it implemented. Let's see. Yeah.
And time and space complexity. So
Yeah.
time complexity is just m times n, which is like the size of the matrix, because we could possibly traverse like every element in our grid. And space complexity is also like the size of the matrix, because we have this visited like set, and this can keep like at most it will keep like every element, I suppose, like in this set. So we're using space in this sense here. Yeah, I think that's good.
Cool. All right.
Okay.
Nice work.
Thank you.
I'm just looking at one piece of code. How I think this range function is might be inefficient. It will generate rows between, or what is this doing right here?
So this is just checking like if it's in the range of like our length of like the rows. So if
Okay.
it's like out of bounds, so if it's not in the range, that means it's out of bounds.
I see. But for each iteration, it's generating a list here, right? It's creating a list of 0, 1, 2, 3.
Okay.
That's what
Okay.
range is doing under the hood, right?
Yeah. Okay.
And same with
You're right,
calls
actually.
here.
Okay.
How can we speed that up?
So I think we can just check like if. So I think instead of calling range like from of the rows, we can just straight up take this like we can take rows, which is like the length of the grid, and I think we can say like if instead of doing this, we can say if this is between like 0 and new row, and then I think something like this. I think. So if 0 is less than new row, I'm just trying to like imagine it in my head right now. This is right. Something seems off about this. Um, if 0 is then we can do this. And then this could possibly be 0. So this is fine. So if it's less than or
But let's just break it down in two. Like
yeah.
this. Just be like, or yeah, like if new row, like the different conditions. If and then if it passes, if it breaks that, just continue. That's the way I like to break it down. Like we can separate this out further. So if not in bounds by row, continue. Because you're trying to do it all in one line there, and it's kind of messing you up a bit. If
Oh, okay. So you're doing it like you're keeping all these conditions like on separate if statements, and then you're just continuing if it's like none of them are,
yeah,
or
if
one
it
of them
does,
is
it's
not. Okay.
easier to usually say like if it doesn't meet this, continue. Versus you're trying to do like if it's in here, but then you'll have to take a not if it because here you're saying it should be like if not new rows in between this, right?
Oh
Not
yes,
so
yes,
that's
you're
why it's
right.
confusing you a bit. So that's why
Yeah.
another way is to do this. Yeah, try it both ways.
Okay. So um, so I guess like let's like split up this. Do you want me to like split it up into like 4 different if statements, like this whole like line
No,
basically?
just the bounds check, right?
Oh, okay. So here, so if not 0 less than or equal to new row, which is rounds minus 1, and we can also do that. We can do this again, but for the columns. So new column, and then columns is 1 and continue. And then here we can reduce this line, and we can just check like this thing right here. I think that's what, and
Yeah.
I'm not sure if this. Let me just actually submit this or like run this because I don't know if my thing is correct here.
You have off by one here.
Yeah, I see it. Okay. Do I even need this actually?
I think that might be it. Nice.
Okay. Yeah.
Yeah.
Okay. Okay.
Cool. Yeah.
Yeah.
Just now that's ov one check there now, which is good.
Okay. Cool.
Like, yeah, just the different ways to break it down. Yeah. Overall, really good job. Like for only solving 100 questions. How do you think you did first?
I think I actually did pretty decent. I think like I definitely I definitely needed like I missed out maybe on some edge cases like on the last question or like the like with the n being like equal to 0, then
Yeah.
we don't need to plant anything. Like I missed out on that like right away.
Mm.
Um for here, I think I'm actually surprised that like I got the whole like code for this like working like right off the gate.
Yeah.
Um and I think overall like I explained my thought process like pretty well like in pseudocode for the most part like before coding. Um
Yeah.
so yeah, I think overall I think I did pretty well.
Yeah. Let's see. Let me see my notes. Yeah, I think you did good. Good thought for both questions. Good thought process. Code is super clean. I like the way you structured it and the code was clean. I think first question you solved pretty easily. You did run into those edge cases, but you're able to figure them out. I think,
Yeah.
yeah, like you implemented BFS well, I would just say the main thing is just getting more reps and timing yourself and get faster. I think it seems like you might have not implemented BFS in a long time,
Yeah, it's been a while. Yeah.
so you're still able to solve it, but in the interview, you should get it faster. Um,
Okay.
but I think that you still did really good to pass. Like that would be a pass on the interview. This is more just like for training
Okay.
because some questions it might not be straightforward, so you need to implement BFS way faster than that because there's other intricacies in the problem that you need to handle with. So if I added a twist to it, or there's a twist to the problem, you would have might have not solved it in time, right? This
Okay.
one is just straight DFS. So I would just make sure to be able to implement BFS a little bit faster. So if you have a question that's a twist to BFS, you could spend more time thinking about the question, then you could just like spit out the code really fast. That's kind of my main thing. So I think yeah, overall, I would just keep doing the interviews the same way you did it. You have a good thought process and writing the code. That was really
Okay.
good. I would just make sure to keep doing what you're doing. The main thing is just take on harder and harder problems and get them done faster and faster while maintaining that same thought process. That's gonna get you because now you just need to get better as well, or like keep doing harder questions. I think in the interview
Yeah.
they're actually gonna only ask you questions that are slightly harder, but you want to be able to do harder questions so that you never fail an interview. And I think you can get there. You have like the good foundation.
Okay. Cool.
Yeah.
Awesome. I guess like actually I have like a couple questions like when it comes to
Sure.
like practicing and stuff.
Mhm.
Um, so like in your playlist, like when you said like maybe focus like a month to month and a half on like data structures only and like
Mhm.
save like the next like month and a half for algorithms. And then from there you kind of like start grinding like the questions like straight up.
Yeah.
So I mean like when you're but like when I'm studying for data structures, like let's say if like I'm studying trees and like the ideas, and like I kind of like I understand for the most part like most of the theory for like all the data structures and like how
Mhm.
they work. But like once I start like let's say like practicing tree questions and like solving them, there's no avoiding like having to learn like a BFS or DFS like trying to practice trees.
Yeah.
Like I'm just gonna have to learn it. Like even if it's not like my month of algorithms, like I'm just gonna have to like look at it.
Yeah.
um
I
okay.
think yeah, definitely. Okay, yeah, when I said learn the data structures, actually, have you tried implementing a tree from scratch?
Yeah, actually, yeah, I did.
Nice, yeah. So try to implement the different data structures from scratch, and then I think
Okay.
DFS and BFS are common patterns for them. But things like
Yeah.
sliding window, two pointers, cyclic sort, using two heaps, topological sort, those are more specific patterns. So probably the basic ones you should even know, like two pointers, probably hash maps, all that stuff.
Okay. Yeah.
But then if you don't know topological sort, that's fine, unless you run into a question where you need to learn it. But I think
Yeah.
when you're focusing on data structures, right? Try implementing from scratch and then learn the basic patterns for those data structures. And then what I mean, like when you're grinding patterns, right? So patterns, one pattern for graphs and trees is topological sort. It actually comes up pretty often. Have you heard of that pattern?
I have, but I haven't even looked at it, so
Yeah.
I'm like
So
avoiding it right now.
when you learn topological sort, you do like 5 or 6 questions using topological sort, essentially. So you start to see all the different questions where topological sort will be used, and then you grind out like learning how to actually implement it fast. So those ones are like when you're going into patterns, those are the ones that you're gonna be. Does that make sense? Like grinding out
Yeah.
harder.
Yeah, it's kind of like yeah, because right now like my study, like the way I study is kind of like I spend a week and a half, right? Like I'm
Mm-hmm.
studying data structures, and every day I kind of so day one is like arrays, and day two is like the next data structure, and day three is like the next one. And then once I go through everything, I kind of loop back to arrays for the next week, like for the new week, and I kind of go from there for like a month and a half. But it's like some data structures, like trees, for example, or like matrices like this, like I'm gonna have to know like to practice those data structures. Like I already have to know kind of like the common algorithm already,
Yeah.
which is like BFS and DFS. Yeah, which was
Okay.
kind of my question. Yeah,
Sick.
yeah,
All right.
okay,
We should actually do one. We'll do one maybe next week or the week before. I'll message you and we can wrap up the questions. I kind of see where I kind of want to see where you're at. I think you solved these ones easy. I could give you slightly harder. I want to see, yeah, sort of where you're at when it comes to how hard the questions are. But I think what
Okay.
you're doing is perfect. Like you're grinding it, you're getting good. I would just keep it up.
Okay, cool. All right, thanks so
All
much,
right,
man.
thanks,
Appreciate
man.
it.
All right, okay, see ya. Peace.
I'll see you. Peace.